Question 3, we have a couple of nomenclature questions to look at. We will start here in this problem by identifying the longest chain, and that ends up being very, very straightforward here because I've drawn this molecule in such a way that our longest chain just goes right down the center of the molecule. And if we count that out, we'll find it's a 10 carbon chain. So we're dealing here with some sort of decane derivative. Now, in terms of numbering that chain, we do have some pi bonds, both an alkyne as well as two alkenes, but because we have an alcohol, those take priority for numbering over the other groups that are present. So we're going to start at the end of the molecule that is closest to the first alcohol. And so that's going to be this end here on the left. And we can number it in the following way. At this point we can name our substituents. And we know at 3 we have a cyclopropyl. Now at carbon 6 we have a thiol. And remember, in some cases the thiol will be part of the parent name. But because in this molecule we have a higher priority group, the alcohol, the thiol becomes a substituent, and we refer to it here as mercapto. And finally at carbon 10 we have an iodine. Now you also may have noticed, and just because we're in organic 2 doesn't mean we can forget about these, we have quite a few chiral centers to worry about. So we'll do those last, but I'm going to put them in so that we don't forget to do them. So carbon 3 is chiral, 4 is chiral, 5, and 6 are all chiral. In addition to that, we have an alkene at 7 and an alkene at 9 that we'll need to establish as E or Z. Let's now put the substituents in alphabetical order. So that's 3 cyclopropyl, 10 iodo, 6 mercapto. And then comes our parent name. And our parent name is going to include our alkenes, our alkyne, and our alcohol. So this is going to be deca. Alkenes come first. So that's 7, 9, diene. Next is the alkyne, 1 ine. And then after that are the alcohols, 4, 5, diol. Last thing we need to do is fill in our stereochemistry. So if we start here with this alkene, clearly we can see our higher priority substituents are on opposite sides. So that makes it on the same side, that makes it 9Z. And the alkene right before it has substituents on opposite sides, so that's 7E. Now, looking at our stereocenters, if we start at carbon 6, the thiol, the sulfur, is higher priority, and then the carbon with the oxygen is higher priority than the carbon bonded to carbons. Our arrow here goes clockwise, and so that's R. Going to the next carbon, the alcohol is highest priority. The carbon with the sulfur is higher priority than the carbon with the oxygen. Arrow goes clockwise, which is R. But in this case, the lowest priority substituent, the hydrogen, points forward, so we have to take the opposite, which is S. Carbon 4, the alcohol is first priority, followed by the carbon with the oxygen, compared to the carbon bonded to carbons. Goes counterclockwise or S. And finally, carbon 3. Carbon 3 is bonded to 3 carbons. So again, we have to go to what they're attached to. To the right, we have a carbon bonded to an oxygen versus the other two, which are carbons just bonded to carbons. So that'll get first priority. The alkyne is a carbon bonded to 3 carbons versus the cyclopropane ring, which is a carbon bonded to 2 carbons. So the alkyne gets priority over the cyclopropane ring, which is clockwise, or R. So overall, we have a name for this molecule of 3R, 4S, 5S, 6R, 7E, 9Z, 3-cyclopropyl, 10-iodo, 6-mercapto, deca 7,9-diene, 1-ine, 4,5-diol. Part B for question 3. A lot more substituents, but in reality, actually an easier problem. First reason it's an easier problem is we're dealing with an aldehyde. And we know with an aldehyde that by definition, the aldehyde carbon is carbon 1. And so we can number that one. We see we have a 7-carbon chain. So we have heptanal. For substituents, we have 3 fluorines. We have an isopropyl group. And then we have a whole bunch of methyls. So fluorine will come first alphabetically. 7, 7, 7, trifluoro. Isopropyl comes next. Then all the methyls, 3, 3, 4, 4, 5, 5, hexamethyl. Heptanal. But we're not quite done yet, because that second carbon, the one with the isopropyl group, is a chiral center. We have first priority for the carbonyl, second priority here because this is a carbon bonded to 3 carbons, and third priority up here. Goes clockwise, so we have R. We don't need a number in front of the R here because it's the only chiral center in the molecule.